Hello, everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be exploring how to mitigate ransomware risks with HashiCorp Vault. My name is Connor Beechnor. I'll be your moderator for this session today, and I'm delighted to welcome both Pedro Coca and Andre Pimentel, who are part of our excellent solution engineering team here at HashiCorp, and they'll be your speakers for today. In terms of the agenda, Pedro will give us a quick run through of the history of ransomware, the threat it poses, and the current trends we're seeing in the market. He'll then hand things over to Andre, who'll take us through how Vault can help mitigate those risks, authentication methods and dynamic secrets, looking at encryption as a service, and then looking at Sentinel policies as well. Just in terms of some general housekeeping before we get started, we will have a live Q&A session at the end. So if you do have any questions, please post those in the chat or the Q&A box at the bottom of your Zoom window, and we'll answer them at the end. Also, just to let you know, this webinar is being recorded and we'll send that out to everyone via email after it's been processed. That usually takes about 24 hours. So with that, over to you, Pedro.
Thanks a million, Connor. Okay, let's start. So we're gonna cover a bit of history of the ransomware attacks and how this industry has evolved. So just this week, before we cover the history and where the industry is going in that regard, just this week, it's something that we updated just a couple of days ago. There was a case in Scandinavia, in the Nordics, a hotel chain that had hundreds of locations across different jurisdictions with a ransomware attack. And imagine, being in a rush, maybe, I don't know, the nature is calling you, maybe you want to invite a special guest into the room, maybe you want to put the kids into bed and you cannot do that because, you are locked out effectively. And imagine that kind of problem, in hundreds of hotels. And we don't have to, and that happened here in Europe. But we don't have to go that far because here in the UK, for those who are listening this webinar from the United Kingdom, we had a ransomware attack in a quite popular supermarket chain. So there are more than 300 stores of Spar that could not operate, could not take payments, and that was just this week. But this is getting even worse. Cyber criminals are targeting assets that are quite relevant. So things like source code repositories are being targeted, and there's malware specifically crafted for hijacking repos in GitHub or maybe in private versions on-prem of the source code repositories, right? So that's a bit of the current state of the matter. So maybe it's good to pause a bit and uncover the history of malware. So back in the good old days in the 80s, for those of you that were born over there, so there was the first example of ransomware. So there was a conference of the World Health Organization around a very hot topic back then. Remember, this is the end of the 90s, and AIDS was very relevant, and someone managed to distribute a Trojan horse in 20,000 floppy disk in that conference. So that person was asking for $189 to be sent to a PO box in Panama. So that was like the first documented case of ransomware. The technical details are now seems like a bit naive. It was hiding some directories. It was renaming AutoExec.bat for those who remember those days of the OS. And then later on, like 7 years later, the academia, there was one conference in the IEEE, in the Security and Privacy Conference. There was a proof of concept. There was a presentation and an implementation of a tool called cryptoviral extortion, and the academia was using cryptography to basically leveraging asymmetric keys, render the files of the victim unusable, right? And that happened in the previous centuries, but in the 21st century we have, in one decade later, a really good example of a Trojan. So there was Archivius that was the primary objective, were Windows-based attack, and it was the first ransomware using RSA encryption. Then if we go 3 years later, we have Loka. And Loka, Winlog, those ransomware pieces were quite interesting, because Loka was a category of ransomware that jumped into mobile devices. So typically in the form of, I don't know, a calculator, some kind of application in secondary markets, not official markets, and something that has seen in the recent years with COVID trackers and some kind of, in theory, like simple applications that hijack the assets. And back then, Loka and Winlog as well, and some others were demanding gift cards. So we see US dollars, then gift cards, and those things as a payment method, right? And there's something that is clearly evolving. That is the kind of rescue that they are demanding. So Winlog is a variant of Loka, and it was one, because you had to dial an international number, you have to input a 6-code digit, and you were basically on hold while the meter of those special numbers was going up, and that was the way to pay the rescue. And then in 2013 we have CryptoLocker, and CryptoLocker was the first ransomware to demand payments in Bitcoin, something that pretty much became the standard in terms of the last decade or so. And in 2016 we have another. 2016, to be honest, was a very prolific, very fertile year in terms of ransomware, and we have Loki, that was a very widespread ransomware. They were producing 500,000 phishing emails per day in the peak, and there were some other variants of and some other ransomwares going around that year. And then probably you remember WannaCry. WannaCry did hit the media in a quite significant manner, and WannaCry was affecting 2,100 computers globally. We are talking about losses around 10 billion, more than 10 billion. So the sheer magnitude of ransomware in the last 4 or 5 years has jumped in terms of quality and quantity. And if we think about ransomware as something that is being done in a not so professional manner, I think we are wrong, because that leap, that qualitative and quantitative leap that I was talking before, is very, very visible, very, very patent in 2018 with GrandCrab. So GrandCrab is a very interesting ransomware. It runs as a service with an affiliate program. So it's now very clear in the last 3-4 years that ransomware is an industry, and is a very mature industry with things like affiliate programs, different units updating the ransomware to avoid antivirus and anti-malware tools. And then we have seen an evolution on the attacks. So we have the Ryuka attack that was targeting companies, like quite big size companies in the assets. And obviously in 2020, the pandemic started, the coronavirus pandemic. And then in the last year, we had DarkSide. And DarkSide, maybe the name is not familiar, but maybe the incident is a bit more familiar. So DarkSide infected a pipeline, the Colonial pipeline, and it was closed for 6 days. And this is a pipeline that is 9,000 kilometers. For those who are not familiar with the international metric system, is something like 5,500 miles, and being being closed for 6 days was a huge story in the media. They ended up paying 4.4 million in bitcoins, and that was a pretty big ransomware attack. So just to make really clear that we are not talking about something that happened like 10, 20 years ago or even more, and we're talking about a very consolidated, very mature industry of criminals, right? So it's affecting all kind of companies everywhere, and that explosion that has happened in the last 3, 4, 5 years. Maybe we were used to that kind of news in the media, maybe once in a decade, once every 4 or 5 years. But now with SolarWinds, Colonial Pipeline, the incident that we were mentioning before, and some others, they seem to occur like on a monthly basis. And there are some names like GVS Foods, one of the main meat manufacturers in the world. They paid a lot of money in a ransomware attack. Berkata, that attack was quite significant, affecting cameras in Tesla factories, in jails, in schools. Kaseya is another example that just happened in July. So all these incidents have happened in the last year and a half. So we see that like more and more often, and is many times in the form of ransomware as a service. So again, is a mature industry, and we are facing that kind of threat. And talking about what are the numbers and what are the figures in the industry that those ransomware attacks are generating, is about like a third of business have been affected, and it take more than a week in average to regain access to the data, according to Kaspersky. And also something that probably needs a bit of an update, because it's from a couple of years ago. The average cost of a data breach is around $3.92 million, according to Ponemon Institute. We're gonna see the patterns, and Andrew is gonna talk later on about how those incidents many times are recurrent because there's not enough mitigation measures. But that's gonna be talked later on. But this is some numbers are pretty worrying, and ransomware attacks are not just encrypting data. Sometimes people do the homework. They do backups. They replicate data, and many times attackers are basically exfiltrating data, and more than 77% are likely to do that, and those numbers are going up. So the predictions for the future are not very good, because the number of attacks will probably continue to grow. Again, right today, the message is something that is a very mature, very organized criminal activity, and it's very hard to find talent to mitigate and to fight that battle. And also cyber insurance also represent a challenge. So this is a trend that is being accelerated in the last few years, and we have seen a bit of the attack vectors, the different sizes, the different shapes, the different forms of the ransomware attacks, what kind of assets they have affected in the past, all kind of industries, and we're going to cover some of the mitigation measures. And with that, I'm going to pass the mic to my colleague Andre, and I hope you enjoy the rest of the session. Thank you.
Thank you very much, Pedro. Thank you very much also, Connor. Let me start sharing my screen. Yeah, can you all see my screen? Can you hear me okay?
Yes.
Good stuff. Okay, hi everyone. My name is Andre Pimentel. I'm a solutions engineer for HashiCorp, and I'll start talking about Vault. Okay, so just a quick introduction to Vault. So when we have the shift from static infrastructure to dynamic infrastructure, changes are happening 100 times a day. You must be using Terraform to deploy 100 apps. You need to do a change on the apps. You pretty much blow everything away and then rebuild everything. Everything is very ephemeral, okay? Fast changes, okay? And this kind of really changes your approach to security, okay? Pretty much, if you are, let's say, on-prem or in one cloud, let's say you're very proficient, let's say with AWS, yeah, you have this high trust perimeter, okay? And then you can see that as a castle with a moat around it. So yeah, you're safe around the castle. There's a big wall. The moat kind of keeps unwanted people away, and everything inside the castle, you pretty much trust, okay? You're comfortable, okay? But how about, let's say, you're scaling up your infrastructure, someone knocks on your door and they say, we need you also deploy to Azure, we need you to deploy to GCP, we need you to deploy to Alibaba. If you tell any InfoSec person that we are deploying to production to a new cloud, they're gonna freak out. And not only that, you have Kubernetes clusters to manage, Internet of Things. Yeah, things are getting crazy. So from this high trust perimeter, we're going to a low trust perimeter. Things are more ephemeral. So we don't have the castle with the moats around this. So they took you away from the castle and they put in the open fields, okay? And you have this kind of places, these tents that you have to manage, and everyone can go there. Okay, we're on the internet now. So the open fields, we need to change our posture to low trust, okay? Zero trust, basically, okay? And that's why we have HashiCorp Vault, okay? HashiCorp Vault is a secrets management solution. HashiCorp Vault is clouds and technology agnostic, okay? It secures, stores, and tightly controls access to secrets in the multi-cloud, okay? Vault uses policy as code to define access to the paths, and Vault is denied by default. We will talk about the two types of policies we have in Vault: the ACL policies, which is the standard policies, and then we'll talk about Sentinel policies also that are more advanced policies and how they can help you mitigate also the risk of ransomware. Okay, just one quick overview also here. So Vault provides a centralized API and a workflow to dynamically manage and consume secrets while enforce auditing and also access based on identity of applications, okay? You can store static secrets in Vault, but the real key here is dynamic secrets, okay? That will allow credentials to be generated just in time and live for a short period of time, okay? So on the left side here, we have the authentication methods, okay? They're components in Vault that perform authentication, and they're responsible for assigning identity and a set of policies to the user, okay? When you authenticate into Vault, the first thing that happens is the policies will also define what you can do and see in Vault. Having multiple authentication methods enables you to use methods that makes more sense for the use case for you and your organization. Let's say developers, they can use Azure AD to connect to Vault, while applications, they can connect using their provider identity, okay? We'll see in the next couple of slides that we don't have to ship our applications infrastructure with environment variables or configuration files with static credentials, which pretty much is just spreading the surface area and creating secret sprawl. Okay. On the right side here, we have the secret engines. They're components in Vault that store, generate, and encrypt data, okay? The secret engines, they're incredibly flexible. So you can think about them as plugins, but you don't have to download them, you just enable them in Vault. And some of them, they just store data, and the other ones, they connect to other services, and they generate the dynamic secrets, dynamic credentials on demand, okay? The best secret is the one that doesn't exist, okay? And when you create a dynamic secret or you enable a secret engines in Vault, you basically create a path, okay? When a request comes to Vault and on a person or app that's authenticated and also has a permission on the path based on the policies, they can do the operations that they are allowed to, basically. Okay, so just like a 10,000-foot overview of Vault. Okay, but wait a minute, what's the Vault role mitigating risks? Okay, we are not talking here about network security, so service mesh, service segmentation, zero trust networks, they are console, okay? Deploying infrastructure according to the best practice and policy as code. This is Terraform, okay? Here, we are talking about how to prevent ransomware. And we need to focus first on how they gain the initial full access. Okay, actually, ransomware is not the problem here. Okay, the problem is how they gain access to a device or an environment in the first place. We see that 80% of the ransomware victims, they suffer a second attack, because usually people think it was a one-time thing. Oh, I'm the victim here. Usually, it must be someone that they open an email. It could be a problem in your infrastructure. Okay, you have secret sprawl, you leak a credential. Okay, there's also data saying that you could be victim of a ransomware. Now, there could be someone lurking in your infrastructure. They got holds of one credential. And this is the worst scenario ever, that they are already in your network, just waiting, and they are spreading their control and also the domain of the applications that they can see and take hold of, okay? And you see here that according to the data breach investigation reports, the second root case of incidents in breach they involve credentials, okay? And if you took a look at the new release, Roger Graham's book, the top ransomware prevention method is to protect credentials. So pretty much Vault helps you to be on the preventive side and not on the victim or investigation side, okay? So to put in more perspective, let's say we make ransomware disappear, okay? Yeah, that's cool, but that doesn't solve the issue and the root cause of how ransomware got into your system in the first place, okay? Or how they hack into environments, okay? Even if you take ransomware away, there's still malware, there's still some other ways that hackers can exploit victims, okay? Ransomware is a symptom of a larger issue, okay? A security vulnerability that got exploits, okay? So if you think about a conversation about moving to the multi-clouds, okay, you have more secrets to manage, more applications, different things coming, more also applications to manage, pipelines, you name it, okay? And maybe when you are still onboarding these new applications and new teams, also they're not proficient with the new technologies, you have vulnerabilities, okay? You have a secret sprawl across different systems, files, new repositories, okay? So yeah, you have to think what happens when you scale to the multi-clouds, okay? Usually people think, yeah, let's go for the easiest route. So if you're adopting a Kubernetes clusters, let's use Kubernetes secrets. But then you realize it's just an encrypted folder somewhere. It doesn't yet solve much, okay? And also there's the increased risk of a data exposure, okay? Multi-cloud creates a larger surface area to secure, okay? And you see that you have databases here, databases there. So encrypting data across hybrid environments is painful and hard to use. Okay, so if you, let's reinvent the wheel and let's create our own in-house solution, let's scaffold around things, is another solution you have to maintain, okay? And maybe there is a vulnerability there, okay? When you scaffold around solutions, let's build the thing ourselves, let's do our own encryption thing, let's manage everything by ourselves. Basically, you're building your own in-house sheds, but there must be like a hole in the ceiling, a issue in the door, okay? It's your solution, yeah, but you have to maintain it. And if the people that are maintaining the solution, they leave the company tomorrow, yeah, that's it, okay? So let's talk about authentication methods and dynamic secrets first, okay? So different cloud systems and endpoints, they introduce new identities with their own permissions and restrictions, okay, for you to manage, okay? The security team, they need a logical way to allow applications that run the multi-cloud to access different endpoints programmatically, okay? And yeah, what happens if you scale up, okay? You adopt new technologies, Internet of Things, Kubernetes clusters again. And what about also legacy applications? How can you make everything also talk to legacy applications, okay? How those applications consume secret security, okay? So Vault provides a centralized API in a workflow to enable applications and operators to leverage their trusted identity and use Vault to broker access to different clouds, okay, systems and endpoints. These allow identities to be translated between platforms and simplify administration for multi-cloud applications. Okay, what does that mean? Okay, let me go for a whiteboard here. Okay, so let's say Vault is here on the center. Okay, and we have here one instance of an application, and let's say this application is running on an EC2 instance on AWS. And in the other hand here, we have another app here, which is running in Azure and is a Kubernetes cluster, is a AKS. And also we have here a human user, okay? So the authentication methods in Vault, they allow you to leverage the platform. So there is no static configuration files here, okay? You don't have to ship or version the source control system static configuration files. And there's also no environment variables. There is no environment variable saying, oh yeah, this is our app role or something. No, okay? Let's say you're in EC2, you do that funny curl call to 169.255, you get a GCHQ token from the AWS endpoint, okay? And when you configure the authentication method in Vault, Vault knows, yes, the configuration for me to talk to AWS and authenticates this EC2 instance, yeah? And I know when they give the GCHQ token, who they are. So I talk to AWS, yes, is that application really who they say they are? Yes. So Vault will authenticate the application, okay, which means that it will give you back a token. The token is tied to a policy, what the application can do in Vault. And also it has a time to live. Everything Vault pretty much has a time to live. Everything is ephemeral. The time to live in authentication methods pretty much says how long your session could last, okay? And that's it. For the Azure is the same. So let's say here we have the Kubernetes authentication methods. Okay, so let's say this application is running under a pod, under a service account, under a Kubernetes namespace. Okay, so when you enable in Vault the Kubernetes authentication methods, Vault can go into that Kubernetes cluster and say, yeah, is that a GCHQ token from that service account, from that Kubernetes namespace, really who they say they are? Yes, so we're going to authenticate that. So no passwords, okay? And for human users, it's the same. You can use Azure AD, Okta, the same. OIDC is extremely secure, okay? And also if I have multiple authentication methods pertinent for a human user, Azure AD, GitHub, etc., Vault can also tie them to a single identity, okay? So for a person, I can centralize all my authentication methods, connect to Vault, also and do the operations that are pertinent for me, okay? And there's no static username and passwords, okay? We're pretty much leveraging the identity platform, okay? For machine-to-machine secrets consumption, this is the gold, okay? So let's go back to the slides, okay? And then, yeah, pretty much what it says that authentication methods, they perform this authentication to verify the user or machine supply information, okay? Some of the support authentication methods are targeted towards users, while others are targeted towards machine or apps, okay? As I said, if you're a human user, you're gonna use Azure AD, Okta, etc. And if you're a machine, you're not a machine, but if there's a machine authenticating to Vault, you can use the platform that the machine is running to also authenticating to Vault, okay? And yeah, beforehand, an admin will pretty much configure the authentication methods, the scope, and the roles of what can be done, okay? Let's talk about dynamic secrets, okay? Dynamic secrets is, yeah, if you read the line there, the future is finally passwordless. It's pretty much what I said about the best secret is the one that doesn't exist. Okay, if you have any human step on secrets distribution, let's say, oh, we need to create an app or deploy an app, let's create a configuration file. That configuration file is somewhere that our human users can see. If a person saw the secrets, it's already too late. Because you never know if they're going to glue it into their monitors, they're going to share with someone. If they leave the company tomorrow, you never know what's going on, okay? So dynamic secrets allow users and applications to quickly and safely add secrets with Vault, okay? When there's a request for a new secret, Vault will go to one of the secret engines, let's say database in this case, and then Vault will create a new username and password based on the scope, okay? Let's go back to the whiteboarding, okay? So maybe I'll create a new one here, okay? So what does that mean? Okay, so let's say I am one application here. Okay, I don't have a database credential to connect to the database. Okay, I am authenticating to Vault. That's done. Okay, that was done in the previous whiteboarding. But I need a username and password for my database. Okay, so when you configure the secrets engine here in Vault, okay, Vault has a set of credentials here. Okay, and when you configure the role in the secrets engine, you can say, yeah, I want a new username and password every time I request it, okay? And the scope is to grant select on db.customers. One example, okay, to that user. I'm really not comfortable on stating SQL in lowercase, yeah, but we did it anyways. So that application doesn't have a username and password to connect to the database. So let's say this is a web app, and the web app needs to connect to the database. So when you request it, Vault will create a new and unique username and password. Okay, that's important, and give it back to that application. Okay, so what's the benefit here? Okay, first, this is a new credential, it's not long-lived. The only way it's being distributed is to that web app. No human users are touching that, no one is seeing that, okay? Second thing, dynamic secrets are ephemeral. There's a time to live, okay? So we can be very aggressive. As long as the application is living, that secret can be lived or renewed, okay? So let's say that web app requests a new username and password, and we can say, yeah, it's valid for a day, a week, etc. Or if we're requesting, let's say, an AWS key pair, we can leave for just 5 minutes. Let's say we need a new AWS key pair to run Terraform. We can be very aggressive. That's gonna last for just 5 minutes. Okay, and then Vault will also manage the lifecycle management of these credentials and terminate after the time to leave is finished. We can absolutely revoke also using the APIs or renew them to extend them. Okay. Also, yeah, we have all the ephemeral secrets here. Another benefit here is that yeah, we have one web app. What happens if we have 100 instances of that web app, not 100, okay? In the old world, we pretty much distribute the same username and password to these 100 instances of the same app, but here, each one of them, they will have the unique username and password. So web app 1, they have username 1, password 1. Web app 2 have username 2 and password 2, and so on. Okay, so not only this is unique, but we can identify which one was the cause of breach and revoke that secret. We have a breakless procedure to revoke the very secret that got compromised. Okay, the benefit here is that we can identify fast. Breakless procedure is fast. And as we're revoking just that secret here, the other web apps, they can continue running. We don't have to have downtime also in our application. Okay. And the same for, let's say, we have here a CI/CD platform that's running Terraform, okay? So they can request AWS key pair, a service principal in Azure, GCP credentials, that funny JSON file, ephemerally, and also that can be very short-lived, okay? So you don't have also long-lived key pairs and etc. for you to manage and be very worried about, okay? So next time you ask your DB team what's the username and password for root, they can say, I don't know, because they can request one from Vault ephemerally, okay? And going back to the slides, yeah. So yeah, applications, they will ask for a database credential rather than setting them as environment variables or config files, okay? The admin here, they need to, enable the database secret engine, configure the secret engine with the credential, and create roles, which will specify the time to leave and also the scope of what those credentials can do, like a do selects on a particular table, or if you are in AWS in a new key pair, let's say it's tied to IAM role to do EC2 star, if you're running Terraform. Each app instance can get unique credentials that don't need to share because it's unique to them. And by making those credentials short-lived, you reduce the chance of they get compromised. Also, you avoid human interaction and SQL sprawl, okay? And if there's any chances of being the app getting compromised, the credentials can be revoked using the API endpoints, okay? So you can control also the blast radius of the revocation. But wait a minute, do you remember that I said that we need to configure first the secrets engine? We can also reduce the surface area by rotating the DB connection passwords immediately after the configuration, okay? Let's say we need to configure a secrets engine in Vault. The credentials that we're using, let's say, is a very permissive, it's a very kind of a privileged DB credential. And it was done by the admin, was made by a person, so that's not good, okay? So we can actually rotate the root password internally, and Vault will be the only place that that credential will be known, okay? So once the root credential was rotated, it's only known by Vault, okay? The same for all the root database credentials given to Vault. So yeah, you should create a separate super user dedicated to Vault for that. But when we had the touch of human admin, we can also revoke that root config, and no human users, they will have privileged GB credentials, okay? Let's talk quickly also about encryption as service with all transits, okay? All application data should be encrypted, okay? But deploying cryptography in key management infrastructure is expensive, hard to develop against, okay? And usually not multi-cloud friendly, okay? If you want to, again, build your own solution to encrypt your own applications, it's going to be hard, okay? And one slip, and you can also increase the risk in making a mistake and exposing data, or also misencrypting or not going across the best practices, okay? So in addition to being able to store secrets, Vault can encrypt and decrypt data that's stored anywhere, okay? The primary user visits to all applications to encrypt the data while still storing in the primary data store, okay? Vault does not store the data, it just centralizes the encryption keys, okay? The transit secrets engines that handles the cryptography functions on data in transits, okay? And it's basically encryption as service. One of the benefits of using encryption as service is the ability to easily rotate encryption keys, okay? You can use the API endpoints, okay? Keys can be rotated automatically, even manually inside Vault, okay? And anything can make an API call. So that's why most of the HashiCorp products, they are API first, okay? If you have a CI pipeline that does it, a periodic, a Nomad job, Kubernetes job, etc., anything today can make an API call and can also reach the endpoints of Vault, but they will do that securely using the authentication methods that we were just talking, okay? So let's think about the following scenario about data exfiltration, okay? We have a company, and they made the headlines for a massive data breach, which exposed millions of the users' payment cards or accounts or any data online, okay? When we have a GDPR breach, yeah, immediately there's a huge fine involved, okay? And if you're talking about exfiltrating data, that's one of the first things that the ransomware people they will do, okay? And if we think about encryption as service, okay, the transits secrets engine enables security teams to fortify data during transit at rest, okay? So even if an intrusion occurs, even if they steal your database, the data will be encrypted, okay? If you check our documentation page, we have several key types and formats, okay? We even use the Cha-Cha one, which is the favorite among the ransomware people, okay? But even if the attacker, they are able to access raw data, they only get encrypted bits, okay? And to decrypt that, the application has to connect to Vault securely, okay? And Vault will host the encryption key, okay? Also, it's also very easy to rotate and also to manage the lifecycle of the encryption keys, okay? If you check our documentation page and you check also about rewrapping, okay? Vault provides very easy way to rewrap encrypt data when the key is also rotated, okay? There's a rewrap API, okay? So a Vault entity can send data encrypted with the old version and have it re-encrypted with the latest version, okay? They don't have to decrypt it. Vault will just say, yeah, I know this is the old version. I'll just re-encrypt it with the new version, so there will be no decryption, okay? The application performing also the rewrapping never interacts with the decrypted data, okay? So you can have also a rewrap job that we never decrypt the data, but we just rewrap using the new encryption key. Okay, so this is very secure. Let's talk about Sentinel policies, okay? So Vault, we have two types of policies. We have ACL policies, pretty much also it's policy as code, but basically saying what authenticated entity can do in a specific path, and also the capabilities, read, write, and etc. Okay, but also we have Sentinel. Okay, if you're familiar with Terraform, you must have heard of Sentinel policies. Okay, Sentinel is a language framework for a policy embedded in Vault Enterprise. Okay, so Vault Enterprise integrates HashiCorp Sentinel to provide a rich set of access control functionality. Because Vault is very secure focused. It's also a trust with high risk secrets and assets. And we have this default deny instance, okay? Integration with Vault is implementing the defense depth fashion, okay? And also Sentinel takes forms of multiple types of policies and a fixed evaluation order, okay? Which means that Sentinel policies, they will happen even before the ACL policies happen, okay? And they provide more fine granular decisions, and also will evaluate the capabilities through this domain specific language, okay? This allows you to solve and introduce complex logical and external information checking, okay? And we've seen the next example that we can also check, let's say, the remote clients, CIDR, HTTP endpoints, and enforce MFA, okay? There's basically two types of Sentinel policies, okay? We have the rule governing policies, the RGPs. There are Sentinel policies tied to specific token, identity entities, and identity groups, okay? That's the one we're gonna see the next example, okay? They have access to a rich set of controls across various aspects of Vault. And we also have endpoint governing policies, okay? The EGPs, if you check our documentation page, it's all there, okay? It's Sentinel policies that are tied to a particular path instead of the token, okay? They allow also verification of the request information, okay? And they take effect even on authentication paths such as login paths, okay? So let's say if we're talking about DDoS or etc., Sentinel can also evaluate the nature of the requester and say that, yeah, they can't even check Vault status, for example, okay? Let's take a look at one quick example here, okay? We have here authorized applications. They are accessing the transit secrets engine, okay, for encrypting or decrypting data, okay? But what if we have here on the corner an authorized entity that appears and try to access the secret engine. They try to impersonate an application. Let's say you have your applications running, they are encrypting data, but there's something trying to impersonate the application, okay? The path-based ACL policies in Vault cannot check the remote origin of a requester. Okay, that's why we have the Sentinel policies. Okay, that's where Sentinel shines. So Sentinel has the ability of querying the remote IP address of the requester and make a decision based on whether the IP address fits a particular CIDR range. Okay, this is just one example. Okay, so let's say your applications are running your network, fine, but there's something trying to impersonate, and that the CIDR is coming from an external network or from like another region. Okay, you have something coming from Russia, from another country that pretty much you don't have any infrastructure or any domains. So this is very suspicious. Okay, so Sentinel can block it before anything happens. Okay, Sentinel will happen before the ACL policies. Okay. If you're also familiar with Sentinel in Terraform, you can restrict any property in any resource. Okay, it's the same principle here. Sentinel is a language, so anything that a Sentinel and the libraries allow you to do, you can do it. Okay. So Sentinel policies are very easy to learn. Okay. I'll talk about that in a second. Okay. But basically here, we are checking the rules of the requester, okay? So this Sentinel policies here, we ensure that only apps on that CIDR address network are able to perform updates operations against the transit path, okay? If you check the precondition here, we are looking for operations that contains updates on transits and nothing more, okay? You see that the main rule will check the precondition condition, and then we'll check the rule that we have to check if the request comes from one of our IP ranges. Okay, so Vault always takes a default denial approach to security. Okay, all active Sentinel policies must pass. Okay, if we have 100 Sentinel policies, 99 pass, 1 fail, it's always denied by default, okay? So if the evaluation condition isn't met, the policy is simply no op, okay? Sentinel also offer enforcement levels, okay? There is hard mandatory policies that they will fail on the spot. Hard mandatory policies they can't be override or anything. There's soft mandatory policies, okay, that a person later can allow it to go through. And advisory, which is good for testing policies, they would just throw a warning, okay? So how do I learn Sentinel? Okay, oh my God, this is very overwhelming. It's different from anything I've seen. No problem, okay? To learn about encryption-as-a-service using transits, to learn more about Sentinel, how to test policies, how to write policies, okay? And also how to create dynamic secrets, authentication methods, ACL policies. I don't know nothing about Vault. We have here the Vault tutorials on learn.hashicorp.com, okay? Each learning trail is pertinent to, let's say, a role or a specific area of knowledge, okay? They are absolutely free, okay? And most of them, they even have a sandbox. So you don't have even to install Vault. You can deploy a sandbox internally, and you can start learning Vault just as easy, okay? I'm an ops person, I need to install Vault in production. No problem, there's a learning trail for that in learn.hashicorp.com. And not only for Vault, okay? But if you go to learn.hashicorp.com, any HashiCorp products, okay? Terraform, Packer, Vagrant, Vault, Boundary, Console, Nomad, Waypoints, HCP, okay? And again, here the learning tracks, okay, for integrations, ops, day one console storage, how to install Vault in production, okay? It's all here, all free, forever, for you. Please check that, okay? for any HashiCorp products, it's a mine of gold. Just being conscious of time, I want to open the floor for any questions. If you can use the chat, or maybe you can also ask any questions that you have now.
Thanks, Andre. I think Pedro's answered a couple of questions in the chat as we've been going through, but we'll give it another couple of seconds. If you do have a question, as we say, please pop that in the chat. We've got one that's just come through actually. So can you briefly highlight what is KMIP?
Yeah, so KMIP is a protocol, okay, for key management and interoperability protocol. Yeah, is a protocol, and Vault has also KMIP secrets engine. Okay, so Vault will offer a KMIP endpoint. Okay, according to that standardized protocol that will allow services applications to perform the cryptographic operations, and without having to manage the material. Okay, the material and the keys are managed by Vault. Okay, so Vault will offer endpoints according to the KMIP specification. Is very similar to transit. Okay, so rotation of the keys, etc., is all managed by Vault. So applications can encrypt database in REST using KMIP. I think is owned by Oasis, yeah, but yeah, we have that secrets engine, but is also enterprise advanced data protection tier feature, if I'm not mistaken.
Fantastic, thanks, Andre. And just kind of a follow-up to that, is this support private endpoint network connectivity instead of a public network?
So yeah, that's a very good question. So depending on your infrastructure, that can be a private endpoint network, a connectivity. If you're having a public endpoint, then you need to be very bulletproof with Sentinel policies, authentication methods, pretty much all the Vault features. Usually people, yeah, they also have multi-cloud deployments with Vault. Vault has also performance application. So you have Vault running AWS cluster, and there's a private endpoint for your AWS applications to use KMIP or whatever. If you're in Azure, you can have also another Vault cluster in Azure, which also expose a private endpoint for the Azure applications. And there's replication across the two clusters, okay? But if you need to expose a public endpoints, then yes, the slides about Sentinel to verify if it's a trusted application, configuring the authentication methods makes sense, okay?
Fabulous. Well, I think with that, it looks like that's the last of our questions. So with that, we'll conclude today's webinar. So a huge thanks to both you, Andre, and to Pedro for your session, and to everyone in the audience as well for joining us today. As Pedro and Andre actually mentioned just now, if you do want to learn a bit more about Vault, then I really encourage you to check out our new Learn site. And you can find that at learn.hashicorp.com/Vault. Also, just a reminder that this webinar was recorded, and we'll share that with you via email as well. So with that, I hope everyone's enjoyed today's session, and we look forward to seeing you next time. Thanks, everyone.